guys, how you guys doing? My name is Edward and I'm here to present Project 12 Homework 5. Again, I'm doing the correction, alright? So let's get right into it. So let's explain first the tangent theorem, alright? So tangent lines is a definition. So the question has some definition, right? Definition: a tangent line meets at a circle at only one point. The theorem states tangent lines are perpendicular to the radii lines. Will be proven later, right? Okay, back here. Homework 5, the question asks, prove the tangent theorem. Let ray xq and ray yq be a tangent line, and let x and y subset circle P R respectively, and then prove prove xq equals to yq, right? So a hint is also given to us. So if you watch the video thoroughly, it says find the tangent lines, right? So see in the image is displayed right to our left, well, to my left, and your finish spot, and your perspective is probably to your right. So either or, right? It could be to your left, it could be your right. I don't know, right? So here we constructed two triangles, right? And also, I'm gonna mention a link. I'm gonna mention a link down in the description below, in which shows you how to construct a triangle, how to construct a tangent line inside a triangle. It's really useful to draw them, and also really helpful when it comes to like drawing out, because some cases you might you might get a misput when it comes to drawing the tangent lines inside a circle, as well as a really good like a really good workout for practicing on your circles. And yeah, but still, if you draw a straight line, right, you construct two triangles, right, and then you say, oh, these two had to be congruent. So the hint of the video shows, wait, you have to prove that these triangles are congruent to each other, thus proving that these two lines are congruent to each other too, are equal to each other, all right? So let's go into the statement justification. Here on the top, I rewrote the given, right? The given is the tangent lines. The tangent lines are bisect at x and y is subset of CPR. Sorry, there's no C. I'm sorry, it's circle PR, right? So P is our point, R is our center point, and R is our radii. So, sorry. So, and also we're trying to show that xq equals to yq, right? So we have four givens, right? We can prove that. Like, hey, xq is tangent line to circle P, right? That's a given, as well as YQ equals is a tangent line to circle P, right? That's also a given, right? That's a given. Measurement of angle XQP equals to 90. Definition of the tangent line states that back in the states that XQ is a perpendicular to XP, right? Because since it's perpendicular, it equals to 90 degrees. As well as measurement of angle QYP equals to 90 degrees also, similar results. However, it's a definite tangent line with line QY equals to PY, right? Since those equal to 90 degrees. As well as also, next step is PQ equals to PQ. Why? Well, the reason for that, it's reflection theorem. Well, since both of them lie in the exact same line, in this case PQ, so they have to lie on each other's line, so that's why it's a reflection theorem, right? Here's another one. XP equals to YP equals R. I mentioned previously, I hope you guys use also the video in bottom description. Why? Because that probably gonna help you out a little more in this step, right? Since we have this is our current step, right? actually pretty help. It pretty much helps you. My bad. But the reason for that is the radii of the circle is equal. How come, per se? Well, if you draw your radii perfectly right, the distance between those two lengths are equal to each other. So at this point, right, at this point, I'm going to mention it clearly. Not clearly, but like you have two option paths. You have two pathways you can mention. One one pathway you can use Pythagoras theorem, right? Like, wait, since we know that xp and yp equals to r, right? We can use substitution for, I'm not sure, line qp, right? Qp could equals a different value, and then we use Pythagoras theorem to solve, hey, what's xq and yq, right? I'm gonna mention it also. I'm gonna probably explain it in the description below, but also I'm gonna mention it here. But first, let me do this pathway that I mentioned, right? This pathway, this method I did, right? So once you figure it out, like, okay, these two things, since we have one line equal to like this line and this line, this yeah, this line xp equals to yp is equal, and these two lines are equal. This line qp is equal to both lengths, then we can prove that triangle xpq x qxp is equal to triangle qyp. The reason for that, it's called the hypotenuse leg theorem. So the hypotenuse leg theorem, if you don't understand the hypotenuse leg theorem, let me explain it to you very clearly or very perfectly to my reason. So the definition states that when two right triangles are congruent if and only if the hypotenuse and the leg of one triangle is congruent to the hypotenuse and the leg of another right triangle. So since we have our hypotenuse and we have our leg are equal to each other, so clearly show that these two triangles are congruent to each other based on the hypotenuse leg theorem. However, you can use the Pythagoras theorem. So I'm gonna write it down in the description below. Don't worry. It's gonna be in the bottom description. I'm gonna mention the steps and the procedure to mention that to how to use it. So one thing you can rewrite back into the XPQ. I will write in description. I'll write in description below. But also by any chance, I'm probably gonna write it here also, based on the magic of editing steps, and then we're actually gonna do it right now. All right. And then the following thing is xq equals to yq. The reason for that, it's step 7 and also corresponding triangles. So that explains that based on the hypotenuse leg theorem, in which the steps is done. All right. Now we're gonna do this. How do we record this? I think I'm still recording. So, all right. So this is how YouTuber does it. Yeah. Down here right now, so it's Q. Yeah, I did a quick little pause and just create the other method because initially I thought I should write down the bottom description. However, I'm strong feeling it might be easier to just explain it in the PowerPoint and also based on a video also because it might be simpler and also might be much more cleaner than in the description below because some of these equations you if you write them via text it might be kind of complicated, it might be kind of but now we're just going to talk about the other method. So the other method, so based on the previous video, based on the previous slide, right? We do have xp equals to yp equals to r, right? So here's our beautiful diagram mentioned beforehand, right? We have xp and yp equals to r, right? Because both are the radius, right? And then also we actually do a substitution here too, right? Hence we have a substitution method, right? PQ equals to S, right? So probably assuming Y because since we know that PQ equals to PQ, and then we can just use the substitution method. Say, hey, this could equals to S, right? Right. So then afterwards, in the previous slide I mentioned using Pythagoras theorem, right? So here we are using it. So in this part, right, we have Pythagoras theorem, which states a squared plus b squared equals c squared. In this case, we substitute those with the line, with the givens or with the previous steps that we mentioned before in the previous video, in which we have all of them grouped together, right? We have qy, right? With qy equals to yp equals to q. I mean, let me back up again. Back up too. Because I'm missing something. Qy squared plus yp squared equals to qp squared. All right, that's for this triangle, right? This triangle in which I'm highlighting, right? And then the other one, it's qx squared plus. This should be this should be xp squared. My bad. I'm probably gonna do that right now. Let's do that right now. Let's actually have a pretty fun time and just. This one turn on. So sorry. Whoops. Can we go? 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 Nope. Well done. Ignore this. This is just an xp. I'm probably gonna put that in the edits. All right. Xp squared equals to qp squared. Right. Here I put pq. Pq is also counted. Also, if you want to put that too. Either way, that works. Right. So then you substitute it. Right. I meant to use substitution method. Right. Since we have those two right are given. Since those two are mentioned, we have qy squared plus r squared equals to s squared, right? And also qx squared plus r squared equals to s squared. Also qx squared, qy squared, right? They're different, however, the rest of them are somewhat the same. And then since you do this, you do basic algebra. You do algebra, right? You substituted s squared to both sides, right? You put s squared, right, to this side, right? And then you have qy squared plus r squared equals to r squared plus qx squared, right? You subtract r squared to both sides because they're both the same, and then you have qy squared equals to qx squared. You square both sides, square root them, and then you just left with qy equals to qx, in which you prove that these two sides are congruent. If you want to double check the math, ignore this part where it says qy squared twice. It should be xp. Yp. It should be xp squared. All right. So make a mental note. I'm probably gonna put that in the description down below to clarify that. All right. So, but still, you saw the previous slide. The following slide, it says thank you so much. Thank you so much, and have a good day or have a good weekend. And yeah, enjoy. Thank you.